Hello everybody, hope you're having a great day today. And today we're going to talk about tree traversals. And so this doesn't have to be binary trees, so it can be any kind of tree, and we're just going to talk about traversals, which are a way to go through every node in the tree and to process the nodes in the tree and figure out to do like different things. So there are different algorithms to process a tree, and we're going to talk about 4 of them today. And so there are pre-order, in-order, post-order, and level by level. And so I hope you're excited, and let's get to it.
So let's get started with tree traversals. So we're going to talk about 4 types of tree traversals, like I stated. And so one of them is pre-order traversal. Then we have the in-order traversal. Then we have the post-order traversal. And then we have the level by level traversal. Okay, so as you might have heard before, there are different names to these. And so these 3 right here are usually called a depth first search, or a DFS right here. And by the name, depth first search is meaning that you're going all the way through all of the nodes, deep into the tree, through all the levels, and trying to traverse through every node. And this one is known as a BFS, or breadth first search, which means that you're trying to go the breadth. So you're trying to go level by level. So if I had a tree something like that here, I'm just drawing a rough sketch here, but a breadth first search would be something like you go to 1 and then you go through all these, you go through 2 and 3. But a DFS would be like you start from 1, you go to 2, and then you see that there's no more left, and then you go to 3. So you keep going the depth, whereas, so you can kind of think of it as like DFS is kind of going vertically down, and a BFS is going horizontally. That's a good way to think about it. And these algorithms, these DFS algorithms, are recursive, so they're done through recursion usually, even though you can do them iteratively, but it's a logical sense that you can do it recursively, and we see why it makes sense like that. And this BFS is usually done with a data structure, and I'll talk about that as well when we talk about level by level traversal. Okay, so let's get started with the DFSs first, because there's 3 of them, and then they're all very similar. So a pre-order traversal, how it works is every tree has a pattern, right? So if I drew something out, again, like I said, it doesn't have to be a binary tree, and what I'm drawing right now is by no means a binary tree. And so I'm just going to write these nodes, and then we'll just connect them so we can see the picture. Oops, actually I don't want that. We'll just go with this here. So this tree right here, um, let me make this 5 node a bit better so it makes more sense. Okay, so let's say this was our tree right here. And so usually how DFSs work, like I said, you want to go all the way down, right? We're trying to go vertically down. And so pre-order, post-order, and in-order, they all have a pattern. So how it works is every tree has a root, right? So in this case, our entire tree right here has a root, but every smaller subtree also has a root. So example, if I were to highlight this is a subtree inside of a bigger tree, and the root would be 2, right? This is a root as well of this smaller subtree. So every tree has a root, and every subtree has a root with children most of the time, right? There are obviously like this one. This is just itself, right? But it is a root, right? So how it works is, I'm just gonna edit that so it doesn't look weird. All right. So how it works is pre-order. There's a pattern. So how we go is it's called pre. So everything is relative to the root. So what this means is we go look at the root first, and then we go left and right. And the reason we do left and right is because this basically aids in any kind of tree, so it doesn't have to be binary tree. This is obviously what we do. We go to the left, we go to the right. But even in other trees, it just makes sense we go left first. You can also go right first if it's not a binary tree, but it's kind of a standard that we go left. So pre-order is this kind of pattern. We start with the root, we process the root, and then we go to the left of the root, we go to the right of the root. So what that means is if we start with the smaller one right here, I'll draw it out here, 2 and so this one right here that I have highlighted right there. What a pre-order would be is I start with the root. So if I were to like process, let's say I was just trying to print them out, the values in the nodes. So I'd print a 2, then I go to the left, which is a 4, and I go to the right, which is a 5. So right of the no, root node, right? So that's how it would work. And usually when they ask you to do this kind of stuff, I'm actually gonna do that. Okay, so when they ask you this kind of stuff, they're usually gonna give you a tree, and they're gonna ask you how to find the what is the pre-order traversal of this tree. right? So if I were to, let's just take this one example, and let me draw it a bit cleaner here because I kind of just scribbled all over it. I don't remember the note specifically, but it shouldn't really matter. We're just trying to understand the pattern here. And so something like this maybe. So if this was our tree, correct? How we would do a pre-order traversal is we start at the root, right? That's how we want to do this. So we start at the root and we print that because that's our pre-order right here, right? We start at the root, so and our processing is just going to be whatever is at, we just print whatever value is at the root. So pre-order traversal would start like this, 1, right? That's the root, and then we go to the left. So we go left here, and so then we're in a subtree because there's children, right? There's more children of the root. So again, we do the same process. We print the 2, and then we go, I'm going to change the color here, and then we go again down, right? And then we print the 3 right here, or 4, sorry, that's the 4. And then we go to the right of this, which is a 5. Then we go all the way back to the root, and then we go to the right of this, right, like here. And so then we look at that, we again go root first, then we check the left. There is no left node, there's nothing there, so we come back here, and then we go to the right again, and then we print a 7. This would be our pre-order traversal, so that's a pattern. Now, in terms of code, how would you go about thinking about this? So it's actually very simple. Since this is a recursion, this is a pattern, so we can keep repeating it over and over again. So how we would do this is something like that. So this is something like this. So we would first process the root, right? That's what we want to do. We want to process. So processing could be just printing the value, or maybe, you know, changing the value somehow or something like that. So we would just process the root. I'm just giving a rough like pseudocode here. I'm not actually coding in some language, but we process the root, and then we would do is we would traverse left, something like this, right? We would traverse left, and how we would do that is usually how we implement it is through the root. So we would just say root.left here, and that just means that go and now do the same process for the left of it, and then we do the same thing. Oops, I forgot an R there. And we do the same thing here, and we say traverse root.right, okay? And so this kind of algorithm, this kind of pseudocode would work because it's doing the same thing. This is doing the root first. This is then looking at the left of the root, and then it's looking for the right of the root. And as I said, a smaller tree is a subtree of the larger tree. So every big tree has many subtrees in it, right? So it's just a recursive pattern. And that's how you do a pre-order traversal. Same thing with a post or in-order traversal. So I'll just erase this. In order just means that, again, we're just going in order, right? Like very literally in order. So we last time we did root first, left, and then right. In order, we're going to do left first, root, and then right. Okay. So we're doing the left node first this time. So again, like if I had another tree, oops, that is a horrible drawing. So again, if I did this, something like that, and then oops, this was my tree. Again, the pattern would still say be similar. I do left first, so this is my root. I start here, correct? And then I go to this left side, and I see this is a subtree, and so I have to go left again, right? I have to keep doing that till I find the most, like leftmost. That's why it's a depth first search. We're going down vertically. So now I go to here, and I see no more children, so I just put a 4 down because that's the left root. And then I go up, and I put this subtree's root, which is our 2, right? That's the subtree's root. And then again, I'm gonna put that arrow there. And then again, I'd go right here, so right this way, and then I would print our 5, right? So here, left, root, and then right. So that's just the root, that's the left, that's the right. Okay. And so same thing, and I'd go back to the root right here because I'm done with this subtree, and then I'm going back, and then so I already went left of the bigger subtree, right? So I already went through this part. Now I have to print the 1 because that's my pattern, right? Left, root, and right. And so I go to the right here, right? I'm going right here. And so then from same thing, it's a subtree, so I have to go left, but there's nothing in the left, so I'm not going to do anything there. And I'm going to print a 3 because I came back from this left because there's nothing there. And then again, I go right again here, and then 7. So that's our in-order traversal, right? And the how you do some pseudocode for it is very similar to the last one. It's just this time you're going to traverse here. Let me write this here. So you're going to traverse the roots left first. Last time we processed it first, right? But this time we're going to traverse left first, and then now we're going to process, because that's their second step. So we're going to process this root, and then we're just going to traverse right of the root. Oops, I don't know why I deleted there. We're going to traverse right of this root. So hopefully I can fit this. Okay, so we traverse left first, right? And then we traverse, and then we process and then we traverse right. So it's the same thing. We're just moving the pieces of code around, kind of, right? And so this one you can actually, like, this obviously doesn't seem like a big difference, but if this was a binary tree, for example, so I'll show a binary tree. And in-order traversal is kind of special in a binary tree because, let's say if we had a binary tree, something like, maybe I started at 5, I go to 2, then I go to 1, and I go to 3, go to a 6, and maybe something like a 7 right here, right? And let me just fix this 3 here. And so if this was like a binary tree, if you follow the same process here, I go to the left, I see this is a subtree, so I have to go left again. I go 1, and I come back, I go to the root, which is a 2, then I go to the right, which is a 3, then I go back here, and then again I have to print the root because that's my in order. So I go to 5, I go to the right here, and there's nothing to the left of the 6, so I don't have to worry about that. And so it essentially just came back here, so I got to 6, and then I go to the right again, 7. So if you see something interesting, that in a binary tree, this actually gives you a sorted order of the node values that you have. So you see this is 1, 2, 3, 4, 5, 6, 7, which is basically the sorted order. So it's a fun, kind of unique thing, and when it's a binary tree, the in-order traversal gives you the whole thing sorted. All right, and that's kind of the thing that you can keep in mind when you're trying to test if you're trying to test if your in order is working. For binary trees, that you have to see that it's in order. All right, and then let's go talk about the post order. And so I think you kind of understand the memo here. The post order is very similar again, same pattern. The post order here, right? Oops. Okay. So the post order is, I'm gonna move this up actually. So let's just erase that. Let me write this here. So the post order, right, is just the same thing, except, so we had, in our in order, we had root left, right, and then in pre-order, we had root left, right. In order, we had left, root, right. And here we have left, right, and then the root. So we do the root last. That's why it's called the post order, the end, right? And so if we go over that again, so something like this. Okay, this is different nodes than before, but you know, it should not matter to us. So if this was our tree, if we did a post order, what we're doing is we're saying, okay, we'll start at the root as always, because that's where that's how we can start on the tree traversal. Start at the root, we go to the left. Okay, that's a subtree, so that means we got to go to the left again. So we go left here, we go 2, we come back, and then we see, okay, that's not the right, that's the root. Then we go to the right. So here we went here, so we get the 2, and then we go right again. After that, we print the 4, and then we come back, and that's the root. So that's why we do the root last. That's our 1, and then we go back again. We have to do the right side first before we can do this root. And so we go to the right, and then we got the 5. That's another subtree. So we go to the left, there's nothing there. Then we go to the right of this smaller subtree, so we get our 6. We come back, we get our root, right? So we got to print that now because that's the end. And then finally we print the root of the larger subtree. So in this, you see the root's always last, right? And so that's how post order works. And again, if you were to again do the pseudocode, we're doing essentially again same stuff. It's just we're doing root left first again, like we did in order. But now we're going to also do right after the left. Okay, something like this. And then we're finally going to process the root. So you see, this is a very simple pattern that just keeps repeating itself. And that's why these are recursive, because it's a pattern. It just keeps repeating for the smaller subtrees. And that's the really cool thing about trees, is that they're recursive, right? And so that's why we're allowed to do this kind of things. And this is why it's a depth first search as well. Any of those 3 algorithms that we talked about, the pre, post, or pre, in, and then post order, all of these are recursive because you're basically repeating the same process and then we're calling the same function here twice. So it's a recursive process. And so that's how you do a post order traversal. And the last but not least is the level by level, also known as the BFS. So how that is done is like this. So this one is not a recursive, so this one actually has an algorithm to it, or a different algorithm to it, not like the other ones. It's not based on a pattern really. And so how a BFS actually would look like in the first place is, say I had a tree like this, something like that, 4, 5, 7. Okay, so if this was our tree, okay, and I'm going to choose a different color here. We want to do a BFS of this, or a level by level. What we would get is 1, 2, 3, and then 4, 5, 7, right? What that is we're going level by level, literally. So this is the first level, second level, third level. And we print everything in each level. So we printed the 1 here first, and then we printed the 2 and 3 here because that was the second level. And then we printed the 4, 5, and 7 from left to right because that was the third level. And so we're just, again, we're always going left to right here. So it doesn't change here. Again, the standard. We're going left to right, and we have to print every node in each level. So how this is accomplished is through a data structure, and the data structure is called a queue, right? So the queue is like it's basically first in, first out, right? So it's like people standing in a line, for example. So how that works is like this. So how the algorithm works is like this. I won't show the pseudocode, but let's just talk about how it works. So what we do is we start at the root again, as usual, right? We always start at the root, and we basically push the root into the queue. Okay, so once we push the root into the queue, there's not, and then we go and check in our queue if there's any node is there, and we have one node, so that's the root that we just pushed in. So we basically push that out, right? And so we process the root, and so we see that's the only thing there, so we print that because that's the only thing on that level. So I'm going to say my results here actually, and so we started with the 1. Then we push every one of the root's children, so 2 and 3, and this is how a queue works, right? So I'm going to push the left first and the right first, and so that's why my 2 is first. And so we push every one of those children, and then we just go to the left. So we go to 2 here. So we're now looking at 2, and so let me just have it. We're looking at 2 now, and so we check, does the 2 have any children? And it does, right? It has 4 and 5. So what we do is we pop the 4 and the 5 again, left and right again. So we pop that onto the stack, or not the stack, we pop that onto the queue, right? And then we go ahead and then we process the 2. And then, so this is gone. So now this is the first thing. 3 is the first thing in our queue. So we process the 3 again, same thing. Does the 3 have any children? And it does, right? It has the 7. So we push the 7 into the queue, and then we process the 3. So we print out the 3, and then we basically take it out of the stack, or the queue. Keep saying stack. Okay, we take it out of the queue, right? And then now we have 4. So does 4 have any children? No. So we can just push this out of the stack, and then we print the 4. 5 have any children? No. So we did that. We take that out as well. Print the 5. Does 7 have any children? No. 7. So with this kind of thing, we are able to look through every single node and every level, and we're able to print that out. And this gives us our BFS, or breadth first, because we're going the entire breadth, or you can think about the width, and essentially we're going through every horizontal level in the tree. And so this can be done, any tree doesn't have to be a binary tree, but that's how this one is drawn. And this one usually is iterative. It's not recursive because you saw there's no real pattern to this. It's just using a data structure like the queue. And so data structure here, and then we use the queue to basically have it as a storage for our nodes while we process them. So this is our storage right here for the nodes.
I hope you enjoyed that video about tree traversals, and if you have any questions about tree traversals, like any of the algorithms that we discussed today, let me know in the comment section below. And also make sure to like the video, subscribe to the channel, and let me know if you have any other video ideas that you want me to make, and let me know in the comment section below as well. And I hope to see you soon. Thanks for watching.